Hello students, sorry I couldn't be there today, but you guys know how this goes. You've done this before. Follow along, grab your headphones, put them in, and upload these notes to your Notability. You will be turning them in at the end of class. Make sure you are now in the second assessment period on Canvas. That's where you can find these notes, and that's where you'll submit these notes and all assignments from this point forward. All right, so let's begin. We're starting our next unit right now. It's an extension of what we were just talking about in the last unit in the first assessment period. Now we are solving, as you can see here, two-step equations, and then eventually equations having like terms and parentheses. So a lot of the great material that we learned last unit, no, not a lot of it, literally all of it, everything that we learned in the last assessment period is going to be used again in this new unit, okay, in which we're solving multi-step equations. Multi-step, in other words, more than one. You know the prefix multi means more than one. So you might remember these properties of equality, the addition, subtraction, multiplication, and division properties of equality. You see, we're going to still use them again. So it's not like, oh, well, now it's a new unit, whole new information. No. Mathematics builds upon itself. So that's one thing we got to keep in mind as we're using this information. So the addition property of equality, if you might remember, let's say for all of these you're solving for the single variable x. And notice we have an a's and b's here. Well, if you want to solve for x, remember what that means. That means you are isolating x. That means you're getting rid of everything that is on the same side as the equal sign of the x. So right now over here we have x minus a is equal to b. On the same side of the equal sign you have a minus a. On the other side you have a b. So don't touch the b. Only touch that minus a. And the way you do that, of course, is you add a to both sides. And as you know, negative a plus a is 0. So you're just going to be left with x is equal to b plus a. Well, with subtraction, very similar. X plus a is equal to b. You want to get rid of that plus a because it's on the same side of the equal sign. So you subtract a from both sides, and there you go. And the positive a minus a becomes 0. And then for multiplication, very similar, except now we have to do the opposite of multiplication, which you might remember is we're dividing, it's x divided by a is equal to b, so we have to, of course, multiply both sides by a, and of course those a's will cancel out. And upon doing so, we're just left with x is equal to b times a, which you can state as ab or ba. And then for division, same thing, you're going to divide the same thing to both sides. Because what happens to the ax and the a? Those cancel out. Because remember, when things cancel out, when you're dividing, very similar to over here, we're so used to them, we think it becomes 0. It doesn't. All right? A divided by a is 1, so we're left with 1x. So please keep that in mind this whole time. The overall rule is always the same, as you can see. Remove the starting operation by using its opposite. Remember, we called those inverse operations, and the inverse operation of addition is subtraction, and of subtraction it's addition, and the inverse operation of multiplication is division, and of division it's multiplication. So keep that in mind. We just saw that with those properties of equality. We saw those in the last unit. We're going to use them again. But before we do that, it's important to know what a solution would be. If we wanted to tell if x is equal to 10 is a solution to this equation, how would we do that? In other words, if we were to take this x and we were to remove it, would 10 fit right there and make this whole thing a true equation? Now, what do I mean by that? Let's try this. Here, I'm going to rewrite this whole thing. It's negative x divided by 5 plus 7 is equal to 5. All right, so notice what I've done here is that there's this kind of big hole missing here. There was once an x there. Well, I have not even written the x. It was there, but it's gone. Because remember, x is a variable, which means it is a placeholder. It's waiting in line for a number to be replaced into it. So instead of the minus x, it's now minus some blank. Well, what is that blank going to be? We have to figure out if 10 can fulfill that blank, if it can fulfill that entry. So let's fill in 10 here. All right, so now we've replaced our x with this 10 because we think, and we're trying to figure out if x equals 10 is a solution. Remember what a solution is. A solution makes the equation true. So let's see here. We got to use now proper order of operations. So we divide here negative 10 divided by 5, which of course is negative 2. And we still have the plus 7 is equal to 5. And we got to figure out, is this a true statement? Negative 2 plus 7 equals 5. Ah, yes, 5 does equal 5. So we know we got it right, which means to answer the question, if x is equal to 10, is the solution? The answer is a resounding and positive yes, it is, because x equals 10. 10 makes the equation true. If you used any other number besides 10, it wouldn't have worked. Now we have another question to ask ourselves. This is kind of weird. When you see this on worksheets and it says colon x equals negative 2, this part is separate right here from the equation. Basically what this is saying is this is the equation, and this part here, is this the solution? Question mark. In other words, if we were to take x is equal to negative 2, replace the x in this equation with negative 2, would that be true or not? So let's figure this out. If we have negative 17 is equal to 4 times blank, notice that I have removed the x and I've replaced it with a set of parentheses. We have to figure out if negative 2 would make this equation work. Basically, we're checking our work. All right, so let's do the math here. First, of course, we have to do 4 times negative 2, which is negative 8, and everything else that has not yet been touched simply comes down around it. All right, so is negative 17 equal to negative 8 plus 9 is positive 1. And we know negative 17 does not equal 1, so therefore, of course not. Is negative 2 a solution? The answer is no, it's not a solution, because it didn't make the equation true. Remember what a solution does. A solution solves the problem. Negative 2 did not solve this problem at all. It did not solve this problem. Negative 17 is not equal to 1. This you know. So therefore, it's not the solution. Does a solution exist? Yes. Is the solution negative 2? No. What is the solution? Well, those are the techniques that we're going to learn about and how to find in this very unit. So let's solve this equation. And also let's check our work. And we check our work by inserting what we think the solution is into the equation. So let's start with before. We were doing 3x is equal to 15. Nice. So of course we divide both sides by which number are we trying to get rid of? The 3 or the 15? Well, the 3 is on the same side of the x, so that's the one we're trying to get rid of. So divide both sides by 3. Those 3's cancel out, and you're left with x is equal to 15 divided by 3, 5. Very good. Now we have to, of course, now check your work. It is such an important tool that I want us to start using it more and more. And the way we do that is we rewrite the original equation. However, wherever you see the x, remove it and replace it with what you think the answer is. The solution, I think, is 5. And let's see if it makes a true equation. And if it does, we got it. And if it doesn't, we got to go back to the drawing board and recalculate. But look at this. 15 does equal 15 because 3 times 5 is 15. So we know for certain x equals 5 is the solution. All right, very good. Now we're going to carry on these very same concepts, but now in 2 steps. Here we have 3x plus 7 is equal to negative 5. Uh-oh. We have to get rid of this 3 and this 7, because those are both on the same side of the x right here. This negative 5 is on the other side. We don't touch that. We don't have to worry about that. So what do we do first? Well, I'll tell you. Do we get rid of the 3 or the 7 first? What do you think? We get rid of the 7 first, and I'll explain why in just a moment. Yeah. And of course it's plus 7 to start with, so therefore to get rid of it we subtract 7. And to subtract 7, well, that would be 3x plus 0, 7 minus 7, is equal to negative 5 minus 7, which is negative 12. Careful with your mathematics here. So now we're back down to one of these, a one-step equation. And the way we get rid of now the 3x is we divide both sides by 3. And as we know, those 3's cancel out. And so you're left with x is equal to negative 12 divided by 3, negative 4. Very good. Very, very good. Now we want to make sure that our answer is correct, and it is negative 4. And the way you're going to do that is, again, you're going to rewrite the equation But notice what I'm doing. Wherever I saw an x, now I'm not going to write the x. No, 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 no. I am going to write a parentheses, and I'm going to replace it with what I think the answer is. I think the answer is -4. Now I'm going to simplify the other side, the left. 3 times -4, because I'm doing proper order of operations, which means, of course, multiplication before addition. So I have to do, let's see here, -12 plus 7 is equal to -5. And so what is -12 plus 7? Ah, yes, it is -5, and -5 does equal -5. So we know we got it. So we know the correct solution, of course, is x equals -4. Nice work. Nice work on that one. So how many steps for each? Well, we noticed that before we were doing 1 step, but now we had 2 steps. And the first step was to subtract 7, and then the second step was to divide both sides by 3. Now we're on 2-step equations, and of course they will get a lot more from now on. So let's try it. Here we have 4x plus 1 is equal to 5. I'm going to do this one with you, and then you'll have some to do on your own. All right, so which one do we get rid of first? Always start with addition or subtraction. We got to get rid of this 1. It's 4x plus 1 is equal to 5. All right, we got to get rid of the 1. So how do you get rid of a plus 1? You subtract 1 from both sides, and you're left with 4x is equal to, let's see here, we know 1 minus 1 is 0, so no need to write anything here. But 5 minus 1, we know that's 4. So we divide both sides by 4, and you're left with x is equal to, well, we know these 4's cancel out, and 4 divided by 4 is, of course, 1. Nice job. All right, well, before we say nice job, we got to make sure that this is a nice job. We got to make sure that 1 is, in fact, the solution by plugging it into our original equation. Now notice what we have here. It's 4 parentheses plus 1 is equal to 5. The variable has been removed, and here we go. Instead of x, we think the solution is 1. Maybe you can already mentally see it, that 4 times 1 plus 1 does equal 5. 4 times 1 is 4, plus 1 is equal to 5, and we know that 5 is equal to 5. Nice job. We know that is correct. We know that is correct. So therefore, we know the solution, of course, is x is equal to 1. Remember, here is a check of your work to make sure that you got the correct answer. What we are looking for in mathematics is x is equal to 1 right here. But remember, everything over here ensures that you have written the proper answer. This next one is for you to try. 1 is equal to 2r plus 9. Ask yourself, which do I get rid of first, the 2 or the 9? I'll give you a clue. The answer to that question begins with the letter N. All right, try it on your own. Pause this. Try it on your own. You can skip this one up here because you notice it just simply repeats itself and you just did it. Ideally, you checked your work. What about this one here? X divided by 2 minus 3 is equal to 1. Which term do you start with? Okay, here's the trick. Here's the thing that if you remember, it's going to help you significantly. You always start with the number that is quote-unquote furthest away from the variable. Furthest away, what does that mean? Well, we know we got to look at the numbers on the same side of the equal sign. We have a minus 3 and we have a 2. This 1 is on the other side of the equal sign, so we don't have to worry about it. It's only the 2 or the minus 3. All right, now let's look at which one is kind of quote-unquote closest. See this 2 right here? It's like right under the x. That's pretty close. But this minus 3, there's some space between that. There's a minus sign between the x and the 3. So that's the one that's furthest away. So we're going to start with the minus 3. And how do we get rid of a minus 3? Keep in mind the properties of equality we learned. That's right, you add 3. And remember, you must add 3 to both sides. So what are you left with? Well, you're left with an x divided by 2 is equal to 1 plus 3, which is 4. Remember, these 3's here, they cancel out, minus 3 plus 3. And then we got to think of how do I get rid of the x divided by 2, our second step to this whole. That's right. You guessed it. You said it. Multiply by 2. Even if you didn't say it out loud, you thought it. I'm sure you did. Multiply both sides by 2, and those 2's cancel out, and you're left with x is equal to 8. But that's not enough. You can't just say, oh yeah, it's x is equal to 8, and move on with your life. No, before you move on with your life, I want you to rewrite the problem, only this time, notice that I have left out the x which was right there, but I'm going to replace it with what I think the answer is, 8. And then I'm going to use proper order of operations. 8 divided by 2, 4, minus 3 is equal to 1. Aha, look at, we got the correct answer because 1 does equal 1. In other words, when you check your work and you get a true statement, 1 does equal 1. The only number that 1 equals is 1. You know you got it right. The correct solution is x is equal to negative 8, and we know we got it right. Remember, always start with the number furthest away from the variable. Why do we do that? Well, it's because algebra is the opposite of arithmetic. It is the opposite of arithmetic. It is the opposite of arithmetic. Remember, order of operations when you're working with arithmetic is parentheses, exponent, multiplication, division, addition, subtraction. You're going down the order of operations. Parentheses, exponent, multiplication, division, addition, subtraction. But because algebra is the opposite, you also have to do the opposite of the order of operations. You have to reverse the order of operations. You have to go in the reverse order of the operations, in which you start with addition and subtraction, then go to multiplication and division. And that is exactly what we did in that other equation. Heck, all of them. We started by adding and subtracting to both sides, not multiplying or dividing. That was our second step. You're going up the order of operations because algebra is the opposite of arithmetic. So if the order of operations in arithmetic says go down, algebra says go up. Do the opposite. Go in reverse. So ask yourself, in this 4x plus 1 is equal to 5, what number do you start getting rid of first? The 4 or the 1? If you said 1, you were correct. You start by subtracting 1 to both sides. Very good. Very, very good. As we just saw that. All right, on that note, here are 2 problems I want you to start with. I want you to try. All right, I'll give you a clue, though. For this one on the left, x divided by 12 plus 13 is equal to 18. Which number are you going to start working with? Getting rid of? The 12 or the 13? Remember, start with either addition or subtraction. It doesn't matter which, as long as it's one of those. If you said start by subtracting 13, give yourself a pat on the back. Nice job. All right, so you're going to work on that one, and I do want you to check your work. I'll be looking for that when you turn this in. And this one on the right, negative 2x minus 47 is equal to negative 11. You're going to start by getting rid of this minus 2 or this minus 47? Minus 47. You determine that, and then check your work. And then you have a few more to do. And as you can see, they get a little bit more involved here. They certainly do. 250 is equal to 124 minus 3x. Do you start with this 124? Or do you start with this minus 3? Negative x divided by 9 minus 12 is equal to negative 23. Do you start with this negative 12? Or do you start with this negative 23? All right, pause this video and start working on those. And if you didn't already, the other 2 as well. Can you also make a solid attempt at these 2? These are tough. These are a bit more challenging. Notice that the entire expression x minus 12 is being divided by 5. The entire expression x plus 8 is being divided by 5. Ooh, so what do you do there? You're free to work with your neighbor on that one, but I do want you to check your work. Pause the video and work on those now. Uh-oh. Decimals. It's okay. Decimals are nothing more than numbers with a few more digits than we'd like to think of, all right? But all the rules that we've been working with, adding the same number, subtracting the same number, multiplying the same number, dividing the same number to both sides still works here. So what are you going to start with? The negative 3.74 or add the 7.19 to both sides? Excuse me, or subtract the 7.19 to both sides. That's right. You're going to subtract 7.19 to both sides. And you just have to be careful with your your multiplication and your division and your addition, subtraction. In other words, all your computation. Pause the video and continue this one. And then check your work. Check your work by plugging in what you think your solution is. Can you try this one now? Try to solve for x, and then check your work. Now we have to figure out the solution for these, word problems. 14 minus the product of 3 and a number is 26. Well, we know the word minus means subtraction. The word product? That's right. Multiplication, very good. And is in mathematics always means the same number. Means the same symbol. Means the equal sign. That's right. Is 26. What do we do with 14 minus the product of 3 and a number? 14 minus, that's kind of weird. We know that subtraction's not commutative. You can't flip-flop in subtraction and get the same answer like you can with addition or multiplication. And let's start with the other part then, the part that's kind of easier. The product of 3 and a number. And a number. Couldn't that number be anything? Yes, it actually could. Well, that's exactly what we're trying to figure out. That a number is some unknown, because if it was not unknown, instead of saying a number, they would have simply given us what that number is. And because it's unknown, we normally give it a variable. Go ahead and give it a good variable. I'll give it x. So the product of 3 and a number is 3 times x. The product means multiplication of 3 and some number is 26. All right, so the product of 3 and a number we have just made into 3x. But we still have this 14 minus business. 14 minus the product of 3 and a number. Well, that's not so bad. We are subtracting the 3 and the number from the 14. So 14 minus has become that part. And then is 26. Is means equal. And then 26 means, well, yeah, you guessed it, 26. Very good. But we still, of course, have to figure out what this answer is. We have to figure out what x is. What do we start with, the 14? Or do we start with the minus 3x? Good. We start by subtracting 14 from both sides. And so what are we left with on the left? Well, we know the 14 minus 14 is 0. So we're left with minus 3x is equal to 26 minus 14. 6 minus 4 is 2. 2 minus 1 is 1. Aha! So we're left with negative 3x is equal to 12. You called it. Divide both sides by negative 3. And so therefore we get x is equal to negative 4. We think our answer is negative 4. Of course, we have to check that. How do we check it again? That's right, you guessed it. We rewrite the problem. But instead of the x, put in a parentheses. And let's put into what we think the parentheses is our solution of negative 4. All right, let's see what we got here. Careful. Proper order of operations now, because we're no longer in arithmetic, we're no longer in algebra, there's no more variable. So 14 minus 3 times negative 4. Let's see here. We got 14. Negative 3 times negative 4. Don't forget, a negative times a negative is a positive 12 is equal to 26. 14 plus 12 is, 26 equals 26. So we know we got it. We know the proper solution is, of course, x is equal to negative 4. Notice that we are doing two steps to these equations. All right, it is now your duty to pause this video and try this one on your own. Negative 16 plus the quotient of a number, and 8 is 15. Quotient, what does that mean? Addition, subtraction, multiplication, or division? Plus, what does that mean? Addition, subtraction, multiplication, or division? Is, what does that mean? Addition, subtraction, multiplication, or division? And then I want you to check your work. And then after you're done doing that one, try this one. All 3 sides of the triangle shown are equal in length. That's good to know. Write 2 equations you can use to find the value of the variables we have an x and a y here, and then find the value of each variable. I recommend working with a partner on that one because that one is tough. But you can do it. Knowing that all three sides of a triangle are equal in length, we know this side is equal to this. We know this side is equal to this. That is a very helpful clue, which means you can create two equations to find the value of the variables and then find the value of each variables. Basically, you're going to solve the two equations that you set up. And then, with whatever time remains, feel free to try these 4, solve, and check your solutions, and then write verbal sentences as an equation, and then solve it. Nice job. Then you can stop. All right, folks. Email if you have questions. You're going to be taking these notes. You're going to submit them into Canvas. It's an exit slip, this whole thing, all right? So make sure you are submitting it before the end of the day. Nice job, everyone. I look forward to seeing you again this week. Again, I apologize for not being able to be there. Have a great day.